So here we continue with explaining the architecture of Arduino Uno. So this has 23 input output pins. So you see on the board on the right top, you see there are pins labeled as from 0 to 13, and then there are these two pins right here. Similarly, right here, there are other pins named accordingly. So some of these pins can be configured as input output pins for digital input output pins. So it means when they are configured as digital input, it means they are set ready to receive the digital signals coming from the external world. Okay, and when they are set as digital output pins, it means these pins are ready to send digital data to the outside world. So remember, digital input and output. Similarly, these pins can be configured to perform some communication of microcontroller with the external world. Let's say, for example, we want to connect this microcontroller to a computer. So here is this board, and the particular pin can be configured to make a serial data transfer from computer to the microcontroller, or from microcontroller to the computer. Similarly, if you have a digital display, LCD display, or some other external peripherals, the pins can be configured to set up the communication. Now, we have timers and counters inside this microcontroller chip. So there are 3 such counters, and each counter has a capacity of 16-bit. So remember, 16-bit timers or counters. The name of these counters and timers are timer / counter 0. This is the first timer or counter. Timer or / counter 1. This is the second timer or counter. And timer / counter 2. This is the third timer or counter. So remember, as I have explained you in the previous module, in the programming, when we write a program, we have to perform some operations in which we have to introduce some delay. For example, I want to light a LED with a gap 1 second on and 1 second off. And in between, I want, so that's the timing. I am specifying for how long I want to LED to be set as on and set as off. So these timers and counters can be used to hold that information. Similarly, if I want to introduce a delay, let's say I want to light a lamp for 1 second and then wait for 1 second before it switches off. So that delay can be introduced through these timers or counters. If I want to count some pulses, count some events, count some numbers based on your programs, we can use this one. Okay. And they also can be used for various operating modes and to perform some interrupt operation. So let's have a look what is interrupt. So before that, we say that this Arduino board or this microcontroller also has inbuilt A to D converter, which will perform analog to digital operation. So the capacity of that A to D converter is 10-bit. So it has a 10-bit resolution. It means, look at this section, there's name as analog in. So we have about A0, A1 up to A5, 6 pins can be used to receive an analog signal, let's say sine wave or continuous signal coming from sensor, for example, which will be given to the board through these pins, and then inside ADC can be set on to perform analog to digital operation. So this is how these pins can be used. And also inside the chip, we have interrupt sections which supports us to perform some operation when there is an interrupt request. Let's say the microcontroller is performing some operation, is busy with some operation, let's say a logic operation or arithmetic, and from external world, from external peripheral, it receives a request. So it goes to the interrupt section, and microcontroller understands that I have received a request from external world. So According to the program, microcontroller continue operating its current operation and at the same time allocates its resources to perform and attend that interrupt request, or it can stop the current operation and go to perform the request received by the interrupt which comes from the external world. So that's the whole purpose of interrupt section. And as I said, there are peripherals, on-chip peripherals, such as display, motor, computer, and so many other things, such as keyboard, which has to interface and communicate with this Arduino board. So there are different communication interfaces, such as USART, stands for Universal Synchronous Asynchronous Receiver Transmitter. Second is SPI, Serial Peripheral Interface. Third is I2C. So, and fourth is PWM, pulse width modulation. So you see, Arduino is such a powerful board which has all these capabilities to perform this specific operation. So remember, we are talking about a specific architecture of Arduino Uno, which is an 8-bit microcontroller which features an architecture of RISC computer. RISC stands for Reduced Instruction Set Computer. So don't miss the previous 3 modules of this particular section to understand what I'm talking about. Okay.